Namaskar my dear students, I am KG Kapoor. Welcome to Industrial Safety and Fire Safety class. In this class, we will learn about fire sprinkler system, which is one of the important subject of fire prevention and protection covered in week 6 of the course. Subject has been indexed into overview, introduction, water sprinkler system, type of fire sprinkler system, sprinkle patterns, size and K factor, design of installation, sprinkle head, temperature rating and color code of visual link system, temperature rating and color code of glass bulb system, periodic testing and maintenance, spare heads, summary and certain references. A sprinkler system consists of pipes along equipment, ceiling, wall that contain water pressure with an additional source of water for a constant flow. Look at the figure 1 on the right hand side. Attached to the pipes, automatic sprinklers are placed at selected locations. When a fire occurs, a seal in the sprinkler head ruptures at a pre-established temperature and a steady stream of water flows. The sprinkler system mainly consists of a fire pump and a yard main, public water main, pumper connections, divisional wall, hydrant and many more parts. This figure is given for a weight pipe automatic sprinkler system. Research shows that sprinklers are an effective and reliable fire suppression strategy for buildings and industrial establishments. Sprinklers are still rare in most places where people are more exposed to fire, including educational buildings, stores and offices, public assembly property, and especially homes where most fire that occurs. Sprinklers are 87% effective. When a sprinkler system fails, the most frequent reason is 65% that the system was turned off prior to the fire. Other reasons include manual intervention that defeated the system 16% and maintenance issue 7% and inappropriate system for type of fire is 5%. There are many sprinkler systems. Popular ones are the wet pipe and dry pipe systems. IS 1510-2002 Guide for Design and Installation of Sprinkler System. Water spraying system of a fire spraying system may be manually operated or automatically operated. Selection depends upon severity of risk and availability of resources. Manually operated system consists of the piping leading to the protected areas is filled with pressurized water up to the wall on it. Manually operated, any of the wall immediately releases water in the corresponding area to extinguish the fire. The application of such manually operated systems are pressure water spraying system for machinery species, pressure water spraying system for exhaust gas fired thermal oil heaters, pressure water spraying systems for special category species and roll-on, roll-up cargo species, and pressure water systems spraying for cargo areas of tankers. The automatically operated system consists of automatically the water spray on the fire area. This system is used where quick response is required to control the fire. There shall not be any manual intervention for that will take the time. In this system, we avoid the manual intervention and we preserve the time. Automatic spray sprinkler system provides a network of sprinkler heads which detect and extinguish fires throughout the protected spaces. This system may be used in accommodation areas and in machinery spaces with certain variations in equipment used and types of variations. Now we will discuss the working of automatic sprinkler system. The sprinkler head is closed by a quartile valve which contains a liquid that expands considerably on heating. When excessively heated, the liquid expands, shatters the bulb, and water will issue from sprinkle head. A reflector plate on the sprinkle head causes the water to spray out over a larger area. There are different types of fire sprinkler systems. As per NFPA 13, there are 4 major types of sprinkler systems: a wet pipe systems, a dry pipe system, deluge system, pre-action system. They are used based on the requirement. On the right side of the figure, we are showing a wet pipe system. This consists of system relief valve, system water pressure, the alarm, drain valve, supply water pressure gauge, and water supply. Wet pipe systems are most common. Water is in the pipes at all the times, released when heat ruptures the seal in sprinkler head. An alarm check valve detects water flow and activates the alarm system. It is applicable where there is no freezing. Other type of sprinkler system is dry pipe system, that is useful where freezing temperature and broken pipes are a problem. Refer to the figure 3. The system consists of a system air pressure gauge, alarm, and a supply water pressure gauge, and then a drain valve for testing whether the system is working or not. It is used in unheated buildings. Air pressure is maintained in the pipes until a sprinkle head ruptures. Air escapes and water enters the pipes and exits through the opened sprinkles. Because of the delay, dry pipe systems are not as effective as wet pipe systems during the early stages of a fire. Exhauster or accelerator are given to speed up. Deluge system is another type of sprinkler system. This is used for high hazard applications, for example, explosive manufacturing unit, petroleum plant. Refer to the figure 4. It consists of a detection system, heat or smoke detector. Why? Because in case of fire, there will be heat or smoke. The detector will detect the heat or smoke. Then there will be air supply system. There will be a releasing panel. On detection of heat or smoke, the air will be released. Then it will actuate the solenoid valve. This solenoid valve, once it extinguishes the main valve, then water will start flowing. Then there will be a supply water pressure gauge to ensure water is always there in the pipeline. There will be a non-return valve to ensure that water is not entering to the pipe reversing. Water is not entering to the reverse mains. Then there will be a drain valve to test the system. In this system, pipes in protected area are empty. All the sprinkles heads are open. A detector signals triggers the system. Water oblique phone to enter pipes and flow from all sprinkles head. Water flows until shut off and system is reset. Reset deluge clapper valve manually with latching mechanism in place. The fourth type system is pre-action system. They are used to protect where water could severely damage property equipment like historical items. Refer to the figure 5. The system consists of a detection system, heat smoke detection systems, air supply system, releasing panel, a solenoid valve, a test valve or drain valve, and non-return valve, then water mains, and the pressure gauge for the supply water gauge. In this system, pipes are not filled with water. All sprinklers heads are of standard types. They are closed. A detection device opens a water valve, water fills the pipes. Water only flows from a sprinkler head if it is opened by heat or by a fire. Water flows until shut off and system is reset. Some of the other types of sprinkler systems are used for special applications. They are explained below. One of them is recycling installations that shall be used to restrict the water damage after extinguishment, avoid closure of the main installation valve, and prevent accidental water damage. A multi-jet sprinkler system under minor circumstances can be considered. For example, the open sprinkler to provide water curtains within the duct of both sides to prevent propagation of the fire through the duct in the absence of dampers. The fast response sprinkles, early response quick suppressor sprinkles, large orifice sprinklers are proposed to be used in the system as per hazardous conditions in the area. The sprinkler pattern. Now we will see what are the type of sprinkler pattern. A conventional pattern produces spherical type of discharge. A spray pattern produces a hemispherical discharge. A sealing or flush pattern is used with the concealed pipe work. A concealed pattern used with the concealed pipe work. Then side wall pattern produces a downward parabolic discharge. Look at the figure 6a for the sprinkler, and the different types of pattern are shown in figure 6b, a conventional type, spray type, and the side wall type. Sprinkler size and K factor is important factors for any type of sprinkler system. The sprinkler K factor should be chosen by analyzing the hazards, design density, minimum operating pressure, ceiling height of the protected area, area of the coverage. K factor can be calculated by following equations: Q flow equal to K under root P, where Q is the flow through sprinkler orifice in liter per minute. P is the pressure at the entry point of the sprinkler in bar. The refer figure 7 at the right hand side. The specification of a sprinkler are printed on the sprinkler head itself. The table gives the nominal orifice size or the thread size. For 10 NB thread size, the mean value of K factor is 57. For dry sprinkler, minimum is 52, maximum is 62. For others, minimum is 54 and the maximum is 60. Where the nominal size of the thread is 15 NB, then mean value of the K factor shall be 80. Now the minimum value in case of dry sprinkler shall be 74 and the maximum value in case of dry sprinkler shall be 86. For others it shall be 76 and 84. The normal orifice size if is 20, which is the normally maximum size, then the mean value of K factor shall be 115, whereas for dry sprinkler is likely to be 106 and the maximum shall be for dry sprinkler 124. For others, the minimum it will be 109 as well as for maximum it will be 121. The installation design of a sprinkler system is very significant. A wrong installation will serve the purpose and defeat the purpose, even will cause more damage. Based on the fire growth and spread potentialities, the occupancy risks are to be categorized under the following class for purpose of design and installation: light hazard class, moderate hazard class, high hazard class, and storage class. Sprinkler types and the sizes are selected based on the hazard as per the following table. The hazard class if is light, the light hazard pattern of the sprinkler shall be light hazard spinny, ceiling or flush, and or side wall type moderate. The nominal orifice size shall be less than 10 mm. The moderate hazard, any type from the above can be used, and the orifice size will be less than 15 mm. For high hazard installations, the conventional or spray pattern only recommended, and the orifice size shall be less than 15 to 20 mm. Sprinkler head plays the important role for entire sprinkler system. It is not so costly system as compared to the entire system. However, a wrong selection of a sprinkler head will defeat the purpose of a sprinkler spraying system. Based on the heat sensitive element, there are two types of sprinkler heads commercially available. One is fusible link, another is glass bulb type. The main distinctions in sprinkler heads are in heat sensitive elements. A fusible link sprinkler head has two metal plates fused together by solder. Solder acts as heat sensitive element of a visual link sprinkler. It melts at designated temperature, plate is separated and pip cap releases and allow water to flow from the head. In a glass valve sprinkler head, the liquid inside the glass valve is heat sensitive. The liquid expands and breaks the glass once it heats on its specified temperature and pip cone releases to allow the water to flow. Other differences are in temperature rating and color coding. A temperature rating and classification and color code for visual link type of sprinkler head are given in the table. The maximum ceiling, it is based on the maximum ceiling temperature, and it is interrelated to temperature rating and the temperature classification as well as appropriate color code. If maximum ceiling temperature is 38 degrees centigrade, then the temperature rating shall be between 57 and 77 degrees centigrade, and the temperature classification is ordinary, it shall be uncolored or black. If temperature of the ceiling is 66 degrees centigrade, then temperature rating shall be 79 to 107 degrees centigrade, then temperature classification deemed to be intermediate, it will be colored white. If temperature of the ceiling is 107 degrees centigrade maximum, then temperature rating shall be 121 to 149 degrees centigrade, and the temperature classification shall be high and color shall be blue. Ceiling temperature is 107 degrees centigrade, then temperature rating shall be 163 to 191 degrees centigrade, and it is rated as extra high and it will be colored red. If maximum ceiling temperature is 191 degrees centigrade, then temperature rating shall be 204 to 246 degrees centigrade, and it is classified as very extra high temperature, and color shall be green. If temperature of the ceiling further exceeds to 246 degrees centigrade, then temperature rating shall be 260 to 302 degrees centigrade. It is classified as ultra high temperature, and the color of the bar of the sprinkler head shall be orange. If the maximum ceiling temperature is 329 degrees centigrade, then temperature rating shall be 340 degrees centigrade, and temperature classification is ultra high. The color code of the sprinkler head shall be orange. This is one of the sprinkler head given in the figure, which is orange in color. Naturally shall be rated at the ultra high temperature up to the ceiling of more than 300 degrees centigrade. It is visual link automatic sprinkler system. Its main parts are deflector, frame, a lever, then a link. It is soldered, that is solder material, and a cap will be there. Now, upon reaching its rated temperature, during a fire, the solder goes directly from solid to liquid, causing the link top to separate, allowing the operating parts to clear the water waves. The table gives the temperature rating, classification, color code for glass bulb type of sprinkler head. The maximum ceiling temperature if is 38 degrees centigrade, then temperature rating shall be 57 degrees centigrade, and temperature classification rated ordinary, the glass bulb colors shall be orange. Now, if temperature is 39 degrees centigrade at the ceiling, then temperature rating shall be 68 degrees centigrade, and it is classified under ordinary class, and the color of the bulb shall be red. If the maximum ceiling temperature is 66 degrees centigrade, temperature rating shall be 79 degrees centigrade, the temperature classification is intermediate, and the color of the bulb shall be green. If the maximum ceiling temperature is 66 degrees centigrade and the temperature rating can also be 93 degrees centigrade, then it is intermediate and the color of the bulb is green. If the maximum ceiling temperature is 107 degrees centigrade and temperature rating is 121 to 149 degrees centigrade, the temperature classification is high and the glass bulb color shall be blue. If maximum ceiling temperature is 149 degrees centigrade and temperature rating is 163 to 191 degrees centigrade. It is classified as extra high and the glass wall color shall be purple. If maximum ceiling temperature is 191 degrees centigrade, then temperature rating shall be 204 to 246 degrees centigrade and it is classified as very extra high temperature and the color of the bulb shall be black. Further to this, if some maximum ceiling temperature exceeds to 246 degrees centigrade, then temperature rating shall be 260 to 302 degrees centigrade and the temperature classification is ultra high and the glass bulb color is black. If maximum ceiling temperature is 625 degrees Fahrenheit or 329 degrees Celsius, then temperature rating shall be 343 degrees centigrade and temperature classification is ultra high and the glass bulb shall be black. The figure shows the bulb type automatic sprinkler system. The main component of the sprinkler head are valve, quartile bulb, a deflector, a yoke and a diaphragm. Water enters from the top and the thread connection is shown. Based on this, the selection shall be made. Type of fitting of automatic sprinkler system is shown in the figure given below. One of them is pendant type shown in the figure 10a, another is upright type shown in figure 10b, next is the sidewall type shown in figure 10c, and other is concealed type shown in figure 10d. The sprinkler system should be checked periodically if we want to make the system effective. There are certain daily checks, there are certain weekly checks, there are certain annual checks. The daily checks are the pressure gauge readings, all the fire pumps run at least 5 minutes, water level of prime tank delivery pressure of pumps, speed and also other parameters are to be checked and recorded. Diesel engine starting mechanism and battery charges the batteries. The diesel engine run at least for 5 minutes. Weekly checks include the visually for obvious defects such as broken or missing parts, external loading, record the reading of various pressure gauges of each installation valve. The water level in fire water tank is to be recorded. The bearing, grease cup and the cap are to be checked and recorded whether they are having sufficient grease or it is to be refilled. The starter contact for the carbon deposition is to be checked. The time taken for operation of alarm gong after opening the drain valve is also to be checked once a week. Half-yearly checks include insulation resistance of pump motors and records shall be maintained. The sprinkler discharge test is to be done by actually operating the sprinkler system. The manual checking devices to be checked by actually operating them once a while. All the sprinkles for proper positioning and the corrosion is to be checked and the report is to be made. In yearly checks, we clean the reservoir, we clean the piping, all the installations are serviced and tested annually. The sprinkler installation and associated equipment are to be checked. Flushing the entire system is done once in a year and all the equipment pertaining to sprinkler system shall be painted at least once in 2 years. For effective availability of a fire fighting system, it is necessary that adequate spares should be kept. In a sprinkler system, the sprinkler head is one of the important parts which we cannot foresee when the system will need the sprinkler head. Why? Because once fire is there, then many sprinkler heads likely to be replaced. The spares of sprinkler heads are kept for prompt replacement, keep easily accessible location, then store under 38 degrees centigrade. If the table given below. Guidelines for stocking the spares are given in the following table. If hazard class is light hazard class, and then 6 sprinklers head of each type are to be kept if the plant is situated in state capital or within 100 km from the state capital. For all other places, we should keep 25 sprinkler head. If hazard class is moderate class, then we have to keep 24 sprinklers of each type if plant is situated in state capitals or within 100 km of the state capitals. Other places, we should keep 50 sprinkler heads. For high hazard installations such as explosive facilities or petroleum plant or solvent plant or alcohol refineries, we should have 36 sprinklers of each type for a plant situated in state capitals or within 100 km from the state capitals. For other places, we should keep at least 100 sprinkler heads. When there are more than one installation within a risk, the above quantity shall also be increased in proportions. To summarize, a sprinkler system consists of a water supply, a supplies, and one or more sprinklers installations that consist of a set of installations, control valves, and a pipe array fitted with sprinkler heads. The sprinkler heads have temperature sensitive element, fusible link or liquid filled valve. Both are having same functions other than aesthetic looks. The sprinkler heads are fitted at specified locations at the roof or ceiling and where necessary between racks, below shelves, inside ovens or stoves or below obstructions. They are also installed on the side walls. A sprinkler first detects a fire and then provide an adequate distribution of water to control or to extinguish it. Functionally, detection of the fire and activation of sprinklers are independent. The sprinklers operate at predetermined temperatures to discharge water over the affected part of the area. The operating temperature is generally selected to suit ambient temperature conditions, and the only sprinklers in the vicinity of fire, that is those which become sufficiently heated, operate. Other means of fighting fires are necessary along with the sprinkler system. It is essential that the sprinkler system should be properly maintained and the sprinkler system should be inspected periodically and maintained all the time. When sprinkler systems are disabled, extra attention should be paid to fire precautions and the appropriate authorities must be informed. Thank you. Namaskar. I am sure you enjoyed the class. Here we are giving some references for your further study.